Good evening, everybody, and welcome to another Reactor Sydney live stream. My name is Nadia. I'll be moderating the session here this evening. Just a quick couple of things. We will be recording this session. It has been asked in one of our questions already, and it'll be uploaded to our YouTube channel and also in the Reactor Sydney event page. I've popped the links in the Q&A. And without further ado, I'm going to hand you over to David. Oh, wait, there was a quick thing as well. We're going to do Q&A at the end, so feel free to pop all your questions in for David in the Q&A box, and we will answer them at the end for you. Without further ado, I'm going to hand it over to David. Thanks, David.
Thanks, Nadia. So just doing a quick audio system check. You can hear me okay, yes?
Yep, it's all good.
Awesome. So hi, everyone. Welcome to this Reactor session. The title of this session is 6 Secrets to Success When Managing Your AI Project. My name is David Goad. I'll introduce myself. So my name is David Goad. I'm what they refer to as the Chief Solution Architect for the Automation and Innovation Hub at the University of Sydney. I actually have a number of roles. That's one of my roles. Basically, what that means is I go around the university trying to find problems and coming up with ideas to solve problems related to student experience and also to the operations of the university using artificial intelligence, robotic process automation, and generally what Gartner would refer to as hyper-automation. So that's what I do as one of my roles. I'm also what they refer to as a Microsoft Regional Director, which is an honorarium that Microsoft bestows on certain individuals. There's about 150 of us globally. And we basically give advice to Microsoft around their strategy with regards to their various products. I'm also a postgraduate fellow at the University of Sydney Business School. I teach digital transformation. My research areas are artificial intelligence and IoT. I'm also a lecturer at the Australian Graduate School of Management, where I teach digital innovation and digital strategy. I'm also a presenter and subject matter expert for them in terms of artificial intelligence and IoT. So I've spent about the last 5 years being an academic and a researcher as well as a consultant. Prior to that, I spent about 20 years in industry, and I've been involved in probably well over 500 or 600 different IT system deployments, and I've been doing artificial intelligence and IoT for the last 5-6 years now, both as a consultant and also as a researcher. So the presentation that I wanted to cover off with you guys tonight is basically going to be a few topics. I thought I'd start off with just talking a little bit about what is artificial intelligence. So remember, this presentation is targeted at those people who are new to AI. So I'm going to talk a little bit about what AI is, talk about some of the concepts related to artificial intelligence, spend about 15-20 minutes talking about that. Then the plan is to talk about the secrets to success in AI, and apologies there, I've got a spelling mistake, so I'll fix that. 6 secrets to success in terms of artificial intelligence. So I'll talk a little bit about what I've learned through all the AI deployments that I've done over the last 5 years. And most of my learnings aren't related specifically to the technology. It's more about how you do deployment. And then hopefully at the end of the session, we'll do a little bit of a Q&A. You guys will have some questions for me. And that's sort of the plan. So about 20 minutes on AI, 20 minutes on secrets to success, and a little bit 20 minutes on Q&A, and we'll be finished by about 6 o'clock. So what is artificial intelligence? There's lots of definitions for this, and I would say there's actually quite a lot of confusion out there in terms of what AI is. But broadly speaking, you think about Microsoft would say that AI kind of falls into sort of 3 key categories. It's generally technology that's designed to make machines look, feel, and act more like human beings. But in terms of these 3 categories, it's partially about reasoning, being able to use machines to basically learn from large and perfect data sets. It's also about understanding. So this is things like interpreting text, voice, images, and it's also about interacting with people in very natural ways. For example, conversational agents, everything from your Amazon Alexa to your Google Home, these kinds of things. So these are sort of the broad suite of technologies. And I say use the term suite because people need to understand that AI is not one single technology. It's a number of different technologies, a number of different types of math, a number of different types of tools. It's a very, very broad suite of technologies that are all designed to make machines look and feel and act more like human beings. Now, you might be asking yourself, why all the hype? Why has artificial intelligence become really popular over the last 3 to 5 years? Everyone's talking about it, right? Because I don't know about you, and I might be dating myself, but it was a few years ago when I did my undergrad in engineering. And even back then, many years ago, we were talking about neural networks, right? So why is AI all of a sudden being something that people are talking about in the last sort of 3 to 5 years? Well, I'd say to you there's three key reasons for this. The first one is we just got a heck of a lot more data, right? They talk about improved sensors, improved telemetry. One of the reasons why I study the Internet of Things as well as artificial intelligence is because the IoT provides the data that goes into the AI, and they both sort of go hand in hand. By some estimates, the amount of data that's been generated in the last 18 months is more than the data generated in the whole history of man. So there's a heaps more data, and the reality is the more data, the better AIs work. So the more, as a consequence of having all this data, you're seeing AI being used to try and make sense and you can get some value out of this data. The second reason why AI is becoming to the forefront in the last few years is just because of the advent of cloud computing. We've all of a sudden in the last 3 to 5 years have this ability to apply large amounts of compute on demand for short periods of time to build these AI models. So, I mean, artificial intelligence, as I said, is about making machines look and feel, act more like human beings. And the way we do that is by building relatively complex mathematical models to represent reality. Those mathematical models, in order to build them, need a lot of on-demand compute. Because we have that now where we can turn on a lot of computing power for short periods of time, that gives us that ability to build those mathematical models. The third reason why I'd say to you that AI is coming to the forefront over the course of the last 3 to 5 years is simply because of the fact that the mathematics that's used to build those mathematical models that represent reality that the AIs use has gotten better. And so if you look at these two charts to the right, they're very illustrative of this idea that how advanced the math has become over the last few years. So the chart at the top right is basically the way you sort of chart to see how people are doing in terms of artificial intelligence is there's these global competitions where all the the specialists in data scientists compete to see who can build the best AI tool set. So this chart to the top right is the results from what they refer to as the ImageNet competition. So every year, ImageNet is where the data scientists get together, compete to see who can build the best AI model to recognize certain images. If you look at the actual chart, you can see that over the course of time, the accuracy or the error rate has dropped significantly and the accuracy has gone up to the point where now machine vision is actually better than human vision. The average human being has an error rate of about 5% when they look at a drawing or graphics in terms of interpreting it. The machine is actually more accurate. So this is an example of the fact that the mathematics in terms of the tool, the AIs for machine vision is actually getting better quite dramatically over the last few years. The chart on the bottom right illustrates the mathematics, the similar competitions related to speech recognition. So you can see that over the course of time, the error rate in terms of speech recognition is decreased as well. But what you'll also notice is that you'll see that the error rate in terms of speech recognition is slightly worse than machine vision. And this is an important point to highlight, and I'll talk about this later on when I go through other slides. The mathematics and the tools in AI are not all the same, right? Machine vision is a technology specifically around the mathematics is probably a little bit more advanced than, say, speech recognition, than, say, natural language processing. They're all different types of artificial intelligence. The math is not all the same. It's not as advanced. What that means is that not all AI is as good as all the other ones. They call it different types of AI. So you combine all these three things together, all this available data, all this on-demand compute, and then you add in better mathematics, and you get cost-effective human-like decision making with artificial intelligence. And so that's why you've seen the use of AI quite considerably go up the last couple of years. There's lots of what I would call novel uses for artificial intelligence. Here's a couple of examples. Some of them are more eclectic than others. For example, you got American Express using them to process, literally trillions of transactions to look for fraud, right? So you're looking at pattern matching to identify, fraudulent transactions, right? You've got John Deere using it to basically make predictions in terms of when you need to, put fertilizer on your agriculture, and so you see AI being used a lot in agriculture. Probably one of the more important uses of AI over the last few years is the idea of using machine vision to read CT scans. Very, very important. If you're a radiologist and you're looking at literally hundreds of different scans a day, it's quite easy for you to miss something. What they have now is they're using machine vision to basically identify those scans that are interpreted as having something wrong with them, to point those out to the radiologist so they can spend more time on those scans that they think are of more concern. And you see that machine vision has gotten a huge uptake in the medical industry because of the advances in it. And probably something that's touched everyone over the course of the last few years. If you've used Spotify or Netflix, you've been exposed to some form of artificial intelligence or machine vision. In that case, is what they refer to as recommendation engines. In the case of Netflix, a lot of people would argue that their single biggest competitive advantage is their ability to predict what people like in terms of movies, right? Netflix has gotten so good at actually using AI to predict what you like that they've stopped doing TV pilots. For those of you who might remember 10, 15 years ago, when they came out with a new TV series, they would usually come out with a TV pilot, the first 1 or 2 shows to test whether people liked it or not. And if people liked the show, then they would actually, then produce the whole season of the TV series. Now Netflix goes straight to not only producing 1 season, but producing 2, 3, even 4 seasons of a TV show because they've gotten so good at predicting what people like. So that's an example of artificial intelligence. And then you get some sort of, like I said, more eclectic oddball uses. For example, Hello Barbie, talking to children using artificial intelligence. One of the examples I like to show is artificial intelligence is something Microsoft's done called Seeing AI. It's just a little video I'm going to play for you guys. It's a little 1-minute video. If the audio doesn't work, let me know. It's just an example of what I think is a really cool way that AI is being used to sort of help people.
Seeing AI is a Microsoft research project for people with visual impairments. The app narrates the world around you by turning the visual world into an audible experience. Point your phone's camera, select a channel, and hear a description. The app recognizes saved friends. Jenny near top right, 3 feet away, describes the people around you, including their emotions. 28-year-old female wearing glasses looking happy. It reads text out loud as it comes into view, like on an envelope. Kim Lawrence, P.O. Box, or a room entrance. Conference 2005. Or scan and read documents like books and letters. The app will guide you and recognize the text with its formatting. Top and left edge is not visible. Hold steady. Lease agreement. This agreement. When paying with cash, the app identifies currency bills. $20 US. When looking for something in your pantry or at the store, use the barcode scanner with audio cues to help you find what you want. Campbell's tomato soup. When available, hear additional product details. Heated microwave bowl on height. And even hear descriptions of images in other apps like Twitter by importing them into Seeing AI. A close-up of Bill Gates. Finally, explore our experimental features like scene descriptions to get a glimpse of the future. I think it's a young girl throwing a frisbee in the park. Experience the world around you with the Seeing AI app from Microsoft.
So I just like using that example because I mean Microsoft actually provides this app for free. You can go download it for your if you're an Apple fan in terms of Apple phones, you can download it for your iPhone. There's a similar app called Envision that you can use for your Android phone. And it's just a really cool example of how advanced the technology has become and how beneficial AI can be in a variety of use cases. Now, so that all being said about the advances in AI and why AI is coming to the forefront, it's not surprising that a lot of people are considering deploying AI, right? So this is some statistics from Gartner. They talk about the fact that pretty much, up to 90% of organizations are talking about doing some form of AI deployment in the next 2 to 3 years. In fact, quite a large percentage are actually looking at doing it in the next year or two, right? So a lot of organizations are and a lot of CIOs are looking at doing AI deployments. So if you guys are considering doing AI deployments, you're not alone. The question that I would put to you is that, and the challenge will be how many of these will actually be successful pilots? And that's the big question that I'm going to try and talk to in terms of this presentation today. One of the challenges you're going to have, and I'll talk a little bit about this later on, a little bit more about this later on when I talk about the things that you need to think about in terms of secrets to success, is this whole issue of change management. I would say to you that I've seen a lot of negative press around artificial intelligence. There's a lot of sort of fear, uncertainty, and doubt that's been generated around this technology. A lot of people just don't understand it. And so when you go, this is results from a survey. If you go and look at the survey, right, you can see that quite a large proportion of people, upwards of 3/4, are worried that AI will, eliminate their jobs. However, once you've actually deployed AI into an organization, that drops down to 1/8. Okay, and there's a reason for that, and that is that AI doesn't eliminate jobs. What it does is it eliminates tasks. Okay, we all have tasks that can be automated. Some have more tasks than others. A recent McKinsey survey showed that, of all the potential jobs out there, only about 5% of jobs could be fully automated given the current state of the artificial intelligence technology. Okay. But what it did show is that about 60% of jobs did have some tasks that could be automated with artificial intelligence. What that tells you is that you're not going to lose your job, or it's highly unlikely that you're going to lose your job from artificial intelligence. What is likely is that most jobs will have some form of impact with AI over the course of the next 3 to 5 years. Okay. So like I said, this is when you're first deploying AI to an organization, people get very nervous, but then when they get to understand it and realize it's about augmentation and support as opposed to job elimination, they become a lot more comfortable around the technology. Some things to think about when you're talking about AI. There are some advantages and there are some disadvantages, and you need to be aware of these technologies. Some of the advantages of AI are that it's better at, I hate to say it, but given the certain scenarios, it's just better at making decisions. Here's a classic example. You guys have seen this probably before, right? Here are two tables. Which table is longer? The reality is they're both the same length, right? But if you look at this graphic, you believe that the table to the left is longer than the table to the right, right? This represents what human beings take shortcuts, or they have what they call cognitive heuristics that they use to handle complex information. And so we take shortcuts as human beings when we make decisions. And the problem is that even though we know we might be taking a shortcut, right, we still make the same decisions, or it's hard for us not to make those decisions. So even though I tell you that both these tables are the same length, you still look at them and go, oh, geez, the table on the left is longer, right? That just reflects how, as human beings, how our brains are wired. And there's a lot of research that talks about this issue of how human beings make decisions, right? For example, there was a very famous piece of research that came out about 20 years ago called prospect theory that won a Nobel Prize. And the idea there was that previously people thought that human beings would weigh up all options in terms of benefits and costs and pick the best option. People don't think like that. People think in terms of losses. They weight losses more importantly as being more important than making gains. What that means is depending on how I put a question to you, if I put a question to you in terms of a loss or as in terms of a gain, I can actually coach you into making a different answer, okay? So I can affect you in terms of how you answer a question depending on how I ask the question, right? We also have all these cognitive heuristics or biases, things that we, there's all kinds of different ones. For example, I talked about loss aversion. Another very famous one, if you're involved in sales, is called anchoring. When people start negotiating a price, as soon as one price gets quoted, that becomes the anchor, and people will talk about deltas off of that. So that's another example of a cognitive bias. And probably the other one, that to point out is that we as human beings are very lazy decision makers. There's all kinds of research that shows that if given the alternatives of making either a better decision, taking more time to make a better decision, or to make a quicker decision, we more often than not will make a quicker decision. It's less optimal. The other thing you have to bear in mind that is we as human beings, we're not good at handling large volumes of information and data, right? So I'm a member of the Rural Fire Service, right? I'm a crew leader there. We talk about the rule of 5, right? There's 5 firefighters that report to a crew leader or a deputy captain. There's 5 deputy captains that report to a group captain. There's 5 group captains report to, and so on and so forth. The reason why we use that rule of 5 is because in an emergency situation, a human being can't handle more than 5 things in their short-term cognitive memory and manage it once, right? So we're just not good at managing a lot of things. Whereas artificial intelligence, the more data you give it, the more volume, velocity, and variety of the data, the better it gets at making decisions. The challenge you're going to have, and this is what we get into, and we can talk about this later in terms of the deployment issues, where you get that middle ground where there's more information than a human can process effectively, but not enough information to make a good AI tool. And this is one of the things that you got to be aware of when you're doing your AI deployments. So those are some of the advantages of AI. There are also quite a few what I would refer to as disadvantages. If you want a really good book to read, there's a lady by the name of Kathy O'Neill. She did her PhD in mathematics. She went on to work in some of the big banks and some of the other big corporates, building AI models to do things like predict fraud, make recommendations around home loans and these kinds of things. And what she does is she writes a book that basically has a whole bunch of case studies about how AI has been used badly, right? It's kind of like a manual of what not to do in terms of artificial intelligence. So if you read that book, she has lots of really good stories, and I would highly recommend it. She talks about various issues in the book. For example, training data bias. There was a very famous story of a researcher in the US who was doing research around machine vision. The researcher put their image into this machine vision tool that they were using to categorize people, and the machine came back and said that she was an ape, right? Turns out the researcher was an African-American female. Turns out that they trained the machine vision tool set on a bunch of white older males. That illustrates that if you don't have the right data set, you can induce bias into your data set, and the AI will make mistakes, right? So this is one of the key issues that you have to think about, is training data bias in your artificial intelligence tool set, right? This other issue that they talk about is this idea of a negative feedback loop. Kathy O'Neill talks about this in her book. In the United States, they were using artificial intelligence tools for police forces to predict where the police force should patrol to catch crime, right? So they would load in all the crime statistics, and the AI would say, based on these models, we think you should patrol this street at this particular point in time. Of course, when they'd go to patrol that street at that particular point in time, they would, of course, find crime. And so you get this negative feedback loop where the AI is looking at a specific spot, and they're patrolling a specific spot, is providing more data, and it's reinforcing the decision that the AI has already made. So you do have this issue that you can get this what they call negative feedback loop. The other challenge you get is things like shortcuts and proxies. Oftentimes when you're working with a data scientist and they can't find the right data, they might use a shortcut or proxy to prove that their model can have a high degree of accuracy, but then they pick the wrong information. Again, a story from Kathy's book, they talk about the fact that they were using AI to predict performance of teachers in Washington State in the United States. And what they found was that the machine was making incorrect assumptions because people were, jacking up the response in terms of the grades the students were getting in previous years. So you have to be careful that the data you put in is not incorrect and is causing the AI to make the wrong decisions. The other challenge you're going to have with artificial intelligence tools, particularly things like deep learning, is this issue of opacity. The fact that, like I built a machine vision tool set about 6 months ago to categorize some photos. It had over 100,000 nodes in the neural network. These tools are good at giving you correlation but not causation. It's hard to tell how they're making the decision, and in a lot of cases that can be a problem. That's why a burgeoning field of research right now is what they call explainable AI, or building tools so you can actually understand the decisions that an AI machine is making. How are people using artificial intelligence tools? A variety of ways, obviously, to automate repetitive manual tasks, improve customer service, reduce costs, augment complex tasks, right, grow revenues. So these are all sort of the top things that people are doing. Some of the things that you have to consider when you're doing AI deployments, and I'll talk about the specific, like I said, about my 6 key learnings, but these are sort of the 6, I would say, considerations that you need to think about. The first one is, if you're making an AI tool set that's going to make decisions automatically, you need to be pretty sure that you have a high degree of security around that tool set. Because obviously if someone hacks into it, you can end up with problems. Case in point, about several years ago, there was a large recall of Jeep CJ Jeeps in the United States. The reason for that is someone hacked into the radio and was able to do nefarious things like, slow the car down and mess around with the airbags and these kinds of things. So if you're going to get a machine, so people are hacking into these tool sets. So if you're going to have a machine or an AI make decisions, and those decisions can in fact impact your physical reality, then you want to make sure it's secured. The other issue is with regards to privacy regulations. A lot of people don't realize that when the GDPR regulation was released out in the EU several years back, there was actually several provisions in that regulation that talked about regulating artificial intelligence. For example, the right to know and the right to not to be discriminated against, which essentially prohibit the use of certain types of AI in certain situations. So you need to be aware of that, the local privacy regulations. Issues with regards to data quality. Obviously, if you're getting AI to make a decision about something and it's got bad data quality issues that can in fact impact that. Ethical design, go back to my previous comments about data bias in terms of training AIs. You got to be careful that AIs are not making the wrong decisions based on unethical scenarios. For example, there are stories or case studies of where financial institutions were using AI to make decisions about, insurance and mortgages. And what the data scientists didn't realize is that they were using postal code or the local equivalent zip code to correlate in the AI model. And what they didn't realize is that where you live is actually a good correlation of your race. So these AI tools are actually making decisions about race, and of course you don't want to do that. So something you need to be worried about. The issues of change management. If AI are making decisions about based on data that you're providing the AI, then if there's issues with regards to how the AI has changed, the data has changed, then the AI may make the wrong decisions. I'll also talk about change management from a people perspective in a minute when I talk about the 6 things to think about. And just finding the right data scientist skills is absolutely going to be critical in the AI deployment. So that was just that's the first section, the first 20 minutes, roughly about right. to talk about a baseline around what artificial intelligence is. Now I wanted to talk about what I would say to you are my sort of 6 secrets to success if you want to have a good artificial intelligence deployment. So secret to success number 1, you really need to understand what your project is. As I said to you previously, there's different types of AI, right? There's different tools that you can use. There's quite a large number of different types of technologies. There's different types of math, right? So if you're going to look at use cases in your organization to potentially deploy artificial intelligence tools, then you really need to define exactly what your project is so that you can then set it up correctly, right? So the first secret to success is understand your project. Think about the industry you're in, the business problem you're trying to solve. What are the types of AI you're going to use? Is it supervised learning? Is it unsupervised learning? It could be reinforcement learning. There could be all kinds of, it could be deep learning. You could be using different things like convolutional neural networks because they're really good with machine vision. There's a lot of different types of AI. So you need to think about the type of AI that you're going to use to solve the business problem. You need to also think about the types of data, where you're going to get the data from, where the data sources are. And you put all that together and that gives you your project scope. And it's important that you think about it in these contexts because when you go off to find resources or to find technologies to do your AI deployment, they're not all created equal, right? I'll tell you for a fact that depending on the vendor you're talking about, they're good at certain forms of AI and not good at other forms of AI. It's just the reality of it, right? They do research and they're all competing, but you're not going to be good at everything. And so the question is figuring out what your thing is and then figure out what the vendor is good at and then matching that up together, right? Which leads me to my second secret to success around artificial intelligence. You really need to understand your consultants. If you're going to use internal people to do the work or you're going to hire people in, or if you're going to use external consultants, you really need to understand what their skill set is, right? Because not all data scientists or consultants are good at all forms of artificial intelligence, right? You want to find a consultant and a vendor, technology vendor, who have proven industry experience in your industry and in the type of problem that you're trying to solve, right? And so, if you look at the Venn diagram, if you sit there and say that I can describe an AI problem in terms of its industry, the type of AI, the type of problem I'm trying to address, and then the infrastructure stack, and you do the intersection in between, that's where your ideal consultant skill set is. You need to find a consultant that has that skill set. And what you'll realize is a lot of consultants and a lot of vendors will say, oh, they're really good in everything. And if you peel back the layers of the onion and you get into the details, you realize they're only good at, they only have experience at certain things. So you need to drill down into and get into the specifics with them around these 3 sort of key areas: industry, experience in the industry, the type of AI, and the infrastructure stack. And the industry experience is absolutely critical because there's this issue in AI, what they refer to as feature engineering, and that requires you to have industry knowledge. The other thing I would say to you, and this just applies to any kind of technology deployment, it's not about the consultancy, it's about the consultants. So if they come into you and they say, oh, we have all this experience, you say, that's great. Show me the people that you're actually going to get to do my deployment. Right? What experience do they have? This is, I would say this is secret to success number 2. And the reason why I point out those 2 ones and that secret to success number 2 about finding the right person is because there is a lot of, I would say, cowboys out there, people who say they know artificial intelligence and don't. Secret to success number 3, make sure you define what success is up front. I see this all the time, right? We bring in the consultants, we scope out the project, we say we're going to do this, solve this particular problem. It might be machine vision, it might be natural language processing, it might be text analytics, it might be a bunch of things. And I say, great. So what are we trying to achieve? We're trying to achieve this. Okay, so what would be the statistics or the metrics that you would use to say that we've been successful? Because the thing about AI is it's actually, as I said, a number of different technologies, a number of different types of mathematics. They all have, you might be talking about, precision or accuracy. There's a whole bunch of different type of metrics. So what you want to do is you want to get your consultants or your data scientists to identify to you up front, right? What is their actual target? What are they saying is successful? Yeah. Because what you're going to find is when you send your data scientists off to go and just start building these AI models and you send your consultants off to build these tools, you'll find that there'll be a natural tendency for them to build something and say, see, it's successful. And you go, yeah, why? Oh, it is, just trust me, right? And this is where you get into problems. So you want to make sure that they set the goalposts up front so that when they get into the problem later on and they have issues, they're not changing the goalposts on you to say that they're being successful, right? So make sure you define success up front. It might sound obvious, but I see this a lot, in these data science AI projects. The 4th secret to success that I would suggest to you is to have a plan. There is no doubt in all the AI projects I've been involved with, there's a large degree of experimentation that goes on part of the data scientists and in the technologists to build the AI solution, right? They're not going to be able to tell you exactly up front how they're going to solve your problem. Hopefully, if they've had experience in your industry and then the types of AI that you're looking to use, right, they'll be able to suggest to you the types of methods and technologies that will have a higher chance of success, but they're not going to be able to guarantee it. They will have to experiment because it'll depend on your data set, on the tools that you have, on your business, that kind of thing. But they should be able to provide you with a plan. They should be able to say, look, based on what you need to do and your business problem, these are the technologies we think are going to be most effective. These are the mathematical methods that we think are going to be most effective. We would recommend doing blah, blah, blah first, and then doing blah, blah, blah first to test that. And then, start to knock off the higher higher probability solutions until they find one that works well. What you get oftentimes is the data scientist just trying things and being very unstructured, and you can end up with a lot of challenges as a result. So make sure that they have a plan up front. My second last secret to success is, I would say to you, beware of the consultant who is heavily reliant on AI automation tools. And I may be a Microsoft regional director, and I support Microsoft. I think they have a great suite of AI technologies. Same with Google. I have experience and certifications in Google technologies, and I do think automated machine learning tools have their place, but I think they have been a bit over advertised. And the reason why I say that is this, right? This chart to the right is an example of all the different things that you need to do when putting an AI solution in, right? So you're going to talk about your project, and you're going to say, this is the problem I'm going to select to fix. Right, this is how I'm going to actually, the technology selection, I'm going to talk about my business case. I'm going to figure out this is what I want to do, right? And then I'm going to actually get some business understanding, go away and figure out, understand that. And then I'm going to do some data acquisition and analysis, right? I'm going to source the data. I'm probably going to have to do some integration to pull the data in, to put it in a spot where I can use it. I might have to do some cleansing and transformation, right? And then I'll have to build some AI models to be able to, predict reality, so I can build the tools to do some automation. This will require some of what they refer to as feature engineering, some feature selection, maybe some model training, maybe some model selection, right? And then I'm going to have to do a model deployment. I'm going to have to integrate that back into the system and do some automation, do maybe some software coding, build in the system. And then once I built the tool and it's working, I'm going to have to set up a process to monitor it. I'm going to have to monitor the performance of the AI, make sure it's still working. Score it. I might have to do some adjustments. I might have to do some change management. If someone has changed something upstream that affects the AI model, I might have to update that. And I'm going to repeat that process. Okay. Most automated machine learning tools that all the vendors produce only do the three things that are in this yellow box here, these yellow boxes here. They're very good at picking the features that are the ones that you want to include in your model. They're very good at training the models, and they're very good at selecting the models. But they don't do all this other stuff, right, that you need your data scientists to do. And the reality of it is, even though the vendors have built a lot of tool sets that really help to make the building of AI and automation solutions easier, right, those tools are generally built with specific use cases in mind. Once you get off the beaten path in terms of the use case, the tools probably won't work as well, and in some cases won't work at all. So yes, absolutely, look at these these automated tools that the vendors provide. They're absolutely a way of getting time to value quicker, and a lot of use cases. But in a lot of use cases, they're not. And if you have a data scientist who's only familiar with using those automated machine learning tools that don't have good skill sets in all these other things, or can't do these things themselves, right? You're going to get into trouble if you get into a use case that's off the beaten path. So I'm saying absolutely use these AI automation tools. The vendors are coming out with new ones all the time. Use them, apply them, they're great things. But beware of consultants who are heavily reliant on that, because if they don't have the basic skill sets around data science and around how to build the models, and if they don't have a good idea of your industry and how to do the feature engineering, right, and the feature selection, you're going to get into trouble, right? So make sure that your consultants have that sort of base level, good quality skill set, and are aware of all these new tools that are coming out to be able to, make the process quicker and faster. And probably the last sort of secret to success that I would say to you, of my 6 secret to success around deploying AI solutions, is this issue of thinking about change management up front. And as I said to you, there's kind of 2 types of change management. There's the change management in terms of the system change management and making sure that you're constantly monitoring the AIs so that if people do change the data in the system, you can update them to make sure they're always working. But there's the people change management. And what I'm referring to here specifically is the people change management, right? Referring back to my previous slides where I talked about the fact that people when you talk to them about AI, initially there's a lot of fear, uncertainty, and doubt, and they're very sensitive about it. But then once they get to use it, they're very comfortable with it, or more comfortable with it. You need to recognize that up front. And so you need to have a bit of a change management program where you're introducing people to technology. You're perhaps doing pilots. You're exposing them to it so they really understand what it means, what it can do, what it can't do. And you're working through that process with them, because you're going to have to go through that change management with people. The other thing that I would say to you is just be aware of this issue with regards to privacy, particularly if you're building AI solutions that are going to be used around human factors, right? As I've said to you previously, there's a lot of regulations such as the GDPR, which govern that. Even in Australia, there's quite a number of different regulations depending on where you geographically are and who you work for, whether it's a government organization or not. There may be different rules and regulations that govern your use of private information. You need to be aware of those, and you need to address them up front and make sure that you're playing within the, as they say, swimming within the flags, right? The other thing you have to be aware of is just because there's no specific legislation that says you can't do something, there are potential brand impacts. Doing things with AI solutions that are doing the wrong thing, and then people find out about it, right, can create a lot of negative brand publicity. So you want to make sure that you think through these things up front from a privacy perspective, from a people impact perspective. And the last thing I would say to you in this regard is there's a well-known thing. If you do any, I just finished a research paper on privacy. There's this thing called the privacy paradox. And what that says is that what people ask for in terms of privacy, in terms of their stated preference, is completely different in terms of the revealed preference in terms of how they act, right? What that means is that people, their expectation sets can change depending on the scenario and the situation, right? And they can have different expectation sets in terms of how you present the problem to them. So you can't take for granted that if you're working within the regulations, that people will be happy with what you're doing. And you can't take for granted that if you have addressed the privacy issues up front, that people won't raise new concerns or different concerns later on. So it's something that you need to consider and be aware of, and make sure you bake that into your sort of how you're planning out your AI deployments, and making sure you're proactively addressing it, because you don't want to end up with negative brand impacts as a result of that. So that was my sort of primer on basic overlay of artificial intelligence. That's my sort of 6 secrets to success. As like I said to you, that was kind of the first 40 minutes of the presentation. I'm now into the question and answer section. Those are my details there. I'll just leave those up while we're doing the Q&A. People should feel free to ping me an email or connect with me on LinkedIn if they have any questions. And yeah, Nadia, did you want to see if there's any questions that people had?
Awesome. So thanks for that, David. We've got a few questions that have come through. The first one is, what would you say is a common misconception about AI?
Well, like, as I said, the first thing is, the first thing is this fact that it's going to eliminate people's jobs, right? Like I said, AI automates tasks, not jobs. Also, the degree to which people think the change is going to come, the change will happen, but it's going to come over a period of time. They talk about this idea that, there's narrow AI and there's general AI. Narrow AI is using AI for a specific, function or process. General AI is like, C-3PO from Star Wars or Data from Star Trek, right? That's applying intelligence learned in one scenario and another. Most futurists would tell you that general AI is like 20 to 30 years off. Narrow AI is very here and now, but there are costs associated with putting that in place. So I think the degree of change is coming, and it's happening now, and it will happen in the near future, but it's going to take time for these AI solutions to be put into place. And so people who are afraid that they're going to lose their job, I just don't think that's real. So I think that's the first misconception, right? I think the second misconception is that if you're a business person, AI is something that a technologist deals with, and you just kind of send them off and do that. I think that as a business person, what I recommend to the business managers or the leadership who are looking at AI solutions is that they should be actively engaged, just by asking some of the average questions that I was, that my 6 secrets to success, these just kind of basic questions. I think you're going to be more successful in the AI deployment if you participate more, right, and get engaged. And it's not that you can make it simple. You can take this complex math and bring it down to a very simple thing. So I think it's a misconception that AI is something you just kind of push off into the corner and some data scientist deals with, and you just leave them do their thing, right? I think you should be engaged, and I think it's something it's something that the business has to work through with the technologies, just like all other technologies are, right? Most technologies, successful technology deployments, rely on the technologists working well with the business people. Sorry, long answer to a short question. Next question, Nadia.
Sure. The next question is, are there popular programming languages using AI?
Yeah, so There's been quite a few languages that have used over the course of years. Most AI folks would tell you that the two ones that are most popular right now, what they refer to as Python and R. I would say R has been more used in the academic space and is coming less to favor. Python is definitely sort of the language of choice now in terms of building AI models and integrating them in with various solutions. And all the vendors support Python as a primary language. They all have various tools to enable you to develop in Python. And there's also quite a lot of open source code out there that you can use as well and that supports Python that you can build models on.
This is actually a good next question. It ties in with Python. It says, in Python standard library, what packages would you say are the most useful for data scientists?
Look, there's a whole, I'll be obtuse in my answer and say it depends on the problem you're trying to solve, right? So there are a bunch of different libraries. Microsoft has theirs, CNTK, right? Google has theirs. They have TensorFlow. There's a bunch of open source libraries that you can use, and there's a bunch of sort of common libraries that are used to do the basic mathematical functions that we use to build AI. You really got to go off and kind of look at the problem that you're talking about and go and research it. And as I said to you previously, depending on the type of problem, one vendor may be better than the other vendors, and you may actually find, at least we've found when we've been building some models, that some of the open source stuff still is better than some of the stuff the vendors are producing. So it depends on the specific application. So you kind of have to shop around on that. But there is some really good stuff that Microsoft produces.
Awesome. We have a question from Mandeep. What are different factors that contribute in effective project management?
Well, so I'll respond by that. I mean, I've been involved in, I don't know, 500 or 600 ID deployments. I'd say that the characteristics of effective project management are the same, whether it's AI versus any other kind of technology deployment. And I would say, look, there's a lot of characteristics that you get from an effective project manager, a program manager. But really, I would say the top three that kind of come to my head are that one, they actually have some subject matter expertise, both from a business and a technology perspective. So it's going to be very hard for a project manager to manage a data science project unless they have some exposure to data science. They don't have to be a developer or a data scientist, but they need to know the language. The second thing is obviously they need to be methodical. Applying standard, project management methodologies are always appropriate. That's one of the things I was trying to get across with my sort of 6 learnings. When people in an AI sense or consultancy sense tell you that, oh, it's unstructured and we just have to go in and play with it, that's, in my opinion, it's a bunch of bump. They can actually structure it very methodically, and you should encourage them to do so. So I would say application and methodology. And I would say the third thing is, for a project manager, is just detail orientation. Getting into the details, asking the questions, challenging your data scientists, challenging your vendors, challenging your consultants, and saying, why are you doing this this way? So those are the 3 things that I would suggest from a project management perspective. They apply to AI, but I also think they apply largely to a lot of other technology deployments as well. Good question. Thank you.
Do you have a favorite use of AI?
Look, I think that where I've seen AI being used the most, and it's interesting. I'll digress for a minute. I did a little bit of an ad hoc survey on LinkedIn a few weeks ago, and I asked people the question. I said, what do you think is the biggest challenge in terms of AI deployment? Is it the resources? Is it the ethics issues? Is it the business case, or is it the finding the use case? And most people came back and said it was finding the use case. And I think this is the challenge. Everyone likes the idea of using AI, and I think it's great, but because they're kind of lacking a little bit of an understanding of the technology, they don't know where it can be used. So that all being said, my favorite use cases right now around artificial intelligence are specifically around machine vision. I said to you at the beginning of the presentation that all different types of AI technology are different. Machine vision is certainly the most advanced, and I've just seen such really cool applications of machine vision. Everything from reading documents. I mean, we use it at the university to read and translate transcripts, right? To processing invoices. That's all machine vision, right? I see some, you can use it for machine vision in terms of cameras, for example, to identify insecure, unsafe conditions, for example, on a factory floor. And even the car I drive now, uses machine vision to make sure that I'm staying in the lanes on the highway, and it comes up with a little alarm if it thinks I'm getting too close to the car in front. So I think that most organizations would find applications and use of machine vision in their organization, and it would be very easy. And the technology, largely due to something called a convolutional neural network, has become very advanced in terms of machine vision, and the accuracy has become very advanced. My second favorite may be natural language processing. I think there's a lot of things you can do with text analytics these days to help make call centers and inbound communications around email and that more effective. But yeah, definitely those would be my two. Good question.
Awesome. What is the difference between AI and machine learning?
I didn't include that slide in this thing, but I actually have a sort of a definitions slide. So there's what they refer to as algorithmic decision making, which is just basically using computers to make decisions, if-then loops. Within that is AI, which is the branch of technology which says that you're using technologies to make machines look more like humans. Within that, and machine learning is a subset of artificial intelligence, and it's really, machine learning refers to the use of mathematical models to make representations of reality. If you can build a mathematical model to make a representation of reality, then you can use that to build an AI toolset. So it's a subset. Machine learning is a subset of artificial intelligence as a technology.
Awesome. How much would an AI consulting firm charge for teaching AI to executive to raise AI fluency for the client?
Yeah, it depends on the consultancy. I mean, I think you've got people here from various countries, from Australia to various parts of Europe and stuff like that. It's really going to depend on the location. I do a lot of what I call master classes, and those master classes, it can be anywhere from 1 hour to a full day. So I did a full day master class for the Bank of China, for example, last year. I've done them for the Australian government. I did a 1 hour master class for Transport New South Wales last month. It really depends on the audience, how long you want to go for, and the local geography. Good AI consultants are, I would say, slightly more expensive than your average IT consultants. That's just because there's fewer of them. It is more of a premium resource, but it's not out of reach. It's not, but it depends. So that's, I guess, my answer to that question.
Great. This one's it's a bit of a mouthful, so bear with me. So the person has asked, Nassim Taleb offers another way to look at big data. Modernity provides too many variables, but too little data per variable. So the spurious relationships grow much, much faster than real information. In other words, big data may mean more information, but it also means more false information. Do you have any views on that?
Well, I think the question illustrates the point I was trying to make earlier about automated machine learning. A good data scientist who has subject matter expertise in an area will be able to look at the models that you build, look at the AIs you build, and tell very quickly whether they're making bad predictions, right? Because I think you're absolutely correct. Just because you have more data doesn't mean it's necessarily good data. Doesn't mean it's necessarily quality data. Doesn't necessarily mean it's accurate data, right? So a good data scientist or the people in your AI delivery team should have decent experience in the subject matter expertise. For example, if you're going to use AI for fraud detection in banking, then the consultancy that you're using should have a background in finance and banking, because they should know, by looking at the data and by looking at the machine, whether it's making logical decisions or not. And so you've highlighted my point earlier, which is that you need to make sure that your consultants have a good grasp of what the business is that you're doing, because this is the challenge with data scientists in general. Data scientists who are pure technologists, you don't have any industry background, they're challenged because they look at the data and they don't know when it doesn't make sense, right? So you got to be able to look at the data and go, you know what, that doesn't make sense to me. That's odd, or that AI is not making the right recommendation. I need to go and investigate that and figure out why. So yeah, your question highlights that point, which is why I think that having skill sets where you have people who understand the business and what is right and actually understand the math, combining those together is where you're going to end up having success. Good question.
Cool. And our last question for this evening is from Mim. How much progress has been made in the area of understanding a body of text / a document using NLP And what level of improvement will GPT-3 bring? How would you rate AI's understanding of what it reads in comparison to human understanding? For example, is it 50% there?
It depends on your use of application, right? There's lots of sort of novel GPT, I'm not pronouncing it right, 3, this idea that you can put some text in and it'll predict the next couple of sentences. In terms of practical application around natural language processing, where I've seen it used quite successfully is things like sentiment analysis, right? Telling where someone's happy or not in the statement that they made. We use it at the university quite regularly around text analytics for inbound emails. So one of the challenges you have is people will send emails into an email inbox and they'll be about different questions. So having the AI basically take a look at the written email and go, oh, this is based on this, which is what they refer to as a classification problem. So saying that this inbound email is actually should be sent to this person because it's about this topic. So you can use natural language processing to do topic analysis, to allocate emails. You can see conversational agents that are using it to be able to answer basic questions or have simple conversations. So I'd say to you that there's some quite good use cases, but I'd also say to you that natural language processing or text analytics or whatever you want to call it is probably not advanced as I would say machine vision is in terms of a technology. So you can use it to great effect, like I said, to support various business processes, but it's not. It needs a little bit more longer to mature. There have been, with the advent of like conversational neural networks, it's improved dramatically. You also have this idea of recurrent neural networks that are using now to like read paragraphs of text, but the technology is not quite there yet. But it is there in terms of, it's in there in terms of language translation. You can see, Microsoft's got some really good tools around that. But yeah, so certain use cases, yes, certain use cases, no. Good question.
Okay. Mim has also said, P.S. fantastic presentation, and thank you, David. We do have just one. This will be the last question for this evening, and it's, can I stick to .NET solutions in AI, or should I learn Python or R?
I would say to you that you're going to end up having to learn Python. It's just not going to hurt. It is becoming the prevalent language to build models in in AI these days. So most consultants, data scientists, people who are doing AI solutions will have a certain degree of fluency in Python. And it's just the reality. It's becoming the sort of default language. So.
Awesome. We've got some great responses coming in with your content, David, saying that it was brilliant, that they've been enjoying it. So it's been really great. I do want to ask this question actually for one person, and they want to just know what is the topic you are writing your thesis on, please.
Well, so I've done a bunch of research. The AI research that I'm doing is mostly around how transparency affects how people perceive AI. So it's about perceptions around the technology. In terms of the thesis, the work I'm doing around IoT is primarily around the things that prevent the adoption of artificial intelligence. So IoT has a lot of issues with relates to things like security, business models, architecture. So it's actually quite a broad-based thesis. As a typical academic, I've kind of wandered all over the place in terms of my thesis over the last few years. So yeah, but thanks for the question. Obviously, someone's been going off and scoping my LinkedIn. So.
That's awesome. So that is all the questions for tonight. I just want to thank you so much, David, for coming on and sharing your 6 secrets to success.
Awesome.
It's been some great content, and for those as well who are still around, I have put a survey link in the Q&A. So if you do want to see more sessions around AI, if you want to see more of David, if you've got any questions for me about the reactor as well, you're more than welcome to reach out to us directly. I just want to say again, thank you to everyone for joining. Thank you so much again, David, and we will see you all next time. Thank you and enjoy your evening.
Awesome. Thanks, guys.